our lecturer Sir Matthew and my fellow friend. Today we would like to present our mini project. So before we present, we would like to introduce ourselves first. And my name is Timothy Juing.
My name is Ferdinand.
My name is Timothy Thomas.
My name is Arnold.
So let us start. This is our project description. We decided to build a rubber band car. The reason we want to build a rubber band car because we want to prove that potential energy can be converted to kinetic energy and make the car moving. We also set a timeline for each phase, including the basic tasks with start and end date. We also already set time that we will finish our project before 1 November 2022. We also estimate our budget to build rubber band car is around 15 ringgit. And I will pass this to Arnold.
Thank you, Timothy. So let's move to objective of this project. The objective for this project is to analyze the kinetic energy that produced. Other than that, to determine the displacement, velocity, work, and kinetic energy. We move to material and cost. For material and cost, we just need to buy ice cream stick, wire mesh, glue, and wooden stick. The rubber band and bottle cap we recycle from Ferdinand, have rubber band, and me bottle cap. The total cost for this project is 13 ringgit 90 cents. And I pass to Timothy.
So I will talk about the result and discussion. So after we finish doing our rubber band car, we decide to take a weight of our rubber band cars. It's around 48 grams, and then we decide to try whether our rubber band car move or not. So after that, we got a result. Times that we get is 1.87 seconds, and the displacement that we get is 2.2 meters. After that, we also decide to count the velocity of the rubber band car, where we use the formula displacement over time taken. Displacement equals to 2.2 meter over 1.87 seconds, and you will get 1.176 meter per second. After that, we try to find the works where we use formula MGS, where M is mass, G is gravity, and S is displacement. So for the mass, we change the unit gram to kilogram, equals to 0.048 times 9.81 times 1.87, and you will get 0.880 joules. After that, we also find the kinetic energy. For the formula, we use 1 over 2 times m and v squared. So 1 over 2 times 0.048 times 1.176 square, and then you will get 0.033 joules for the kinetic energy. So I will pass the presentation to Ferdinand.
So for the impact is, by stretching out an elastic band, you are creating potential energy. With the rubber band cars, the rubber is made up all long polymer chain that in their natural state are all wrinkled up. When you wind up the rubber bands to power the car, you're forcing the polymer chains to strengthen out, which create elastic potential energy. On the other hand, the more you stretch the rubber, the more potential energy is stored, and the further and faster the car should go. So that is all presentation about our mini project, and thank you.
Thank you.